Recording. Okay, today is uh, October 16th, 2019. This is the regularly scheduled meeting of ITSC 2309. Stephen Smith speaking at Collin College. And today, a couple of things. We wanted to go over the tests that we had, and it's pretty much a different test each time, but I have several that I give. They're all pretty close to the same thing. If you were to look at it, and I've graded them all and handed them back. So if you have questions on the test, I'll answer a question on the test. If you have a question on how did I arrive at your particular grade, I'll take that privately. Okay. Or in a chat or something. Let's see, where were we? It's here. Okay, the first one was just start off with write the SQL code to create at least 2 tables. I say at least because there are some solutions where you have a table in between the two that acts as a linking table or a joining table or whatever you want to call it. And we will talk about that when that happens. And let's see, I gave you doctors and patients. So I told you I was going to give you a one-to-many relationship where you had a parent table and a child table, and you had to insert some things into the parent table to create the parent table. There are a whole bunch of different things I can give. I give, I don't know, vehicles and manuals. A manual may cover many different vehicles. A vehicle is covered, well, that would be a bad one. Owners and cars. An owner has many cars. A car has exactly one owner. Doctor has many patients. Patients has exactly one doctor. Go on and on with that. A teacher has many students. A student has one teacher, which isn't so, but it'll work okay for our discussion. And basically, I was in part 1. I was looking for you to do something like this. Okay, I was looking for you to use ScratchDB. I see a lot of people are using the APDB for creating tables. Scratch essentially means scratch paper. Scratch means that anything you want to throw and save it someplace in the database, you're free to save it to the ScratchDB anytime you want to create a table. If you want to delete the table, just delete the table. I'm never going to ask for it again. So it's just you should not be using AP_DB here. So object ID patients is not null. I'm looking for this because if you're doing a creation script, you're probably going to need to run it multiple times. So if object ID patients, in other words, if it exists, drop it. And you're going to have to do this for each table. It just, it's going to happen. And it's going to happen that you're going to end up with a table named similar names that has a foreign key into one that's named doctors, and you won't be able to drop doctors. So you'll have to be able to go and find that in your Solution Explorer or your, what am I calling it? Object Explorer. But anyway, I'm looking for these 2 things. I'm looking for them to happen in the correct order. What happens first? Is anybody listening to me? What happens first? Drop what? Which table first? I'm not looking for patients. What table gets dropped first? Always. Which one? The one that the child table that has the foreign key has to get dropped first. That might be patients, it might be anything, but if it's got a foreign key, I have to drop that table first. Okay, then I can drop the parent table. Then I create the parent table first. So I create them in reverse order. This one has Dr. ID. I create the fields, and then I add in the constraints is the typical way. There's no particular order to it. I always create the primary key is the first one I create. That's just my way of doing it, but you don't have to do it that way. then names, address, phone. Okay. Constraint, my first constraint is the doctor's primary key. I create all of my fields and then I add in the constraints. The fact of the matter is that when you create, it happens all at once. So I think you can create the constraint even before the field is created. Don't hold me to that. It might not be so, but I think you can do the constraint first. I might try it in a second just to see. I personally like it this way better. It seems to work out logically for me. Now, when I said don't have blank space inside of a statement, and usually we don't because SQL Server doesn't care. SQL Server will let you have blank space in there, but other platforms will not. So don't have blank space in the statement. But between the statements, down here, is fine. Between the SQL queries is fine. Just do whatever you want to do there. Before the create statement, go. After the create statement, go. Before you do anything else. Then we have another create statement. Okay, before this one is a go. So the go separates the two. When I finish, go. That's the only time that we right now have to use go. Some people will write SQL queries, select from where, go, select from where, go. Yeah, you can do that, but there's no particular reason to do so. Doesn't hurt anything, I don't suppose. So then I'm looking for the constraint, the primary key, named constraint. Some people will just put DID char4 primary key. Yeah, that works. That's lazy. That's sloppy. It is better to name it because if it has a name, I can work with it a lot easier later if I need to drop that constraint or something. I don't have to recreate the whole table. Again, patients, patient ID, name, then the doctor ID gets copied down, and I don't have a comma after this one. I should have. The primary key of the parent gets copied into the child. I always keep the same name, but it doesn't have to have the same name. It must have the same type. So it's char4 up there. It has to be char4 down here. They have to match in type. They should match, if possible, in name. Might not be possible, but if you can. Then I have my primary key constraint. Then I have the foreign key constraint. It's foreign key makes it now the foreign key does not make it not null. The foreign key says that if you have one, it has to be in the doctor's table. Then I insert. Go ahead.
What can you do with the constraint with patient's primary key?
I'm sorry, I'm not understanding your question.
Yeah, what's the benefit of naming the constraint? For example, patient's primary key, how could you use that name?
The question is, what is the benefit of naming the constraint? There are several benefits to it. Number one, if you violate that constraint later, and it won't always be like a primary key, if you violate it later, you will see that name pop up in the error message that you get. It may be a cryptic error message if you're working in a web page someplace, but you will always see that if you violate the constraint, the name of the constraint will always be a part of the error message. But that might be the only thing that you see that you recognize in there. It might just have a bunch of cryptic numbers in there. The other thing is that constraints can be disabled. A primary key cannot, but a foreign key can be. Okay, so sometimes people will just say, instead of putting the constraint, they'll just say PID, and then here they will just say primary key. And then the other thing is a foreign key, so sometimes here they'll just say references doctors, shorthand. Yes, it will work, but it's very difficult. I can disable that foreign key if I need to put something in there. Okay, insert into doctors. I'm looking for the values, the field list. Some people just said insert into doctors values. If you say insert into doctor's values, then you have to know the order in which it was created. But you might not know that. You might have to insert into a table where you don't know the order. So we always use, or at least we teach it always, using a field list. If I don't want to insert everything, I don't have to. I just don't put it. If I don't want to put the phone, I don't have to put the phone. I just don't have the phone here, and then I don't have it here. I can change the order of them any way I like. Insert into patients, the same thing. I list the fields. I don't have to have them all. Of course, I'll have to have a PID and list them. Now, I always put the foreign key last. I choose to put the foreign key last. I noticed that some of you weren't doing that, and that's fine. You just weren't doing it the way I do it. It doesn't hurt anything to put it. Some people put the primary key and then the foreign key right after it. That makes perfect sense to me. So some people put the doctor ID right after the patient ID. Yeah, okay, fine. But the main thing is that the doctor ID has to match one that is in the doctor's table. So I have to have this 123, which is the doctor ID, must already be in the doctor's table. There's no reason you can't populate the doctor's table and then put a patient in, and then another doctor, and then another patient for that doctor. That would be fine. But this is what I'm looking for. I was lenient on the format of the date. I went ahead and accepted it, even if that didn't work. What else was I going to say? Most people either got that one or they didn't. And there was quite a few people missed. They did not put in the foreign key. Well, the foreign key is what makes that patient have that doctor. So I can put in another patient that has the foreign key of 123. I can put in 100 patients with the foreign key of 123, or 0 patients can have that foreign key. So that's what gives us the relational database. That's the foundation, utter foundation of database. You have to understand that before you can understand a database. Questions? Moving on. Insert a record into the vendors table for 5 points. Most people got that. Let me see, enable it. Okay, so thought this was my solutions. Well, there's a few solutions in here. Basically, I'm looking for an insert into vendors. So insert, and then the values into vendors. And almost everybody got that one correct. Almost everybody got the 5 points on that one. This one is number 2 is an update statement that would change the terms ID to 7 for all invoices. So update invoices. Now I'm saying for invoices, so some people were updating terms. So I'm saying update invoices. So update invoices, set terms ID equal to 7, where vendor ID is 115. And then I say, don't worry about the error message, just write the code. So here I would be looking for update set where and whether you put it on 3 lines or 2 lines didn't matter. I didn't worry a whole lot about that. And it gives you an error message, foreign key violation. And but that's 5 points, but that's what I'm looking for. And then now you can start worrying about that. Why did that produce the error message? And if all you told me was foreign key violation, I said, yeah, I know that. Why was there a foreign key violation? So I was looking for you to be more explicit about it. Why did it get a foreign key violation? It got a foreign key violation because there's no 7 in the terms table. Now, if you went over there and put 1 in there, which is fine, if you want to do that, you can go ahead and do that, then it would take it. But in the under AP, by the way, we're running on AP_DB here. If you had used Scratch DB, then what you have is all of your tables are over there in Scratch DB. Okay, so that's not a good thing to have. So what I'm looking for here is there's no 7 in the parent table, or there's no such value as 7, terms ID 7 in the terms table. So it's got a foreign key. I'm updating a foreign key to something that doesn't exist. And you'd fix it by either putting a 7 in there or changing it to something that's in there. Saying, oh, this is just an update statement. Update to vendors, set vendor zip code to 93710, where vendor zip code is 93711, and that will change them all. If there's more than one, they'll get changed. That is considered a fairly risky thing to do. I would be a little leery of that, but that's the way it happens, and sometimes I need it. I would definitely select all of the one I'm changing, 93710. I would definitely select that first and make sure I wasn't changing 14 million records or something. No. And take a look at it, make sure, double check that kind of stuff. 10%, 4 through 7, write SQL code. I was fairly happy with this one, to delete vendor ID 82 from the vendors table. And I gave you a hint there. You also need to delete the invoices. So you have to delete from the invoices table first, then you delete from the vendors table. So it's 2 SQL statements. There is a way you can do it, and I didn't see anybody do it, but just you say delete from vendors where vendor ID equals 82, cascade constraints. So if you say that at the end, and I haven't talked about that a whole lot, just because I don't teach SQL that way, but you're saying ignore the constraint. And cascade means it's like a cascade could be a waterfall where it hits and splashes down, or a marble rolling down the stairway. It drops from one step to the other to the other. So that's a cascade. And cascade says drop the, if it has, let's see, so we're dropping the child. If it has a parent, drop the parent. Oops. Okay. And that's known as the resume generator because it deletes other records than the one you specified. So the way you should do that is you delete the delete the parent, and it deletes the child. So we want to delete the parent, delete the child first, then back up and delete the parent, if that's what you want to do. Most people got that 10 points. I'm going to have to rewrite number 6. I was lenient on number 6 because I realized so many people were missing if it made sense. 559 area code. I guess I'm just getting old, folks. I'm realizing that my students don't know what an area code is. We in the day back when I was a kid, you know, I had to walk to school 2 miles through the snow. And we had an area code, and we had to memorize our area code because you only used it when you were away from home, calling home from college or something, needed them sending you some money. I mean, you just didn't call long distance in the first place because it was real expensive. I remember when we called my grandmother, it would cost like $4 a minute or something like that. So we had to talk pretty fast in today's money. Well, today phones just have 10-digit numbers, so the area code is just part of the phone number. So I'm going to have to either tell people what that is or change that. But I was looking for vendors in California, so we're selecting from vendors. So the vendor name, vendor city, from vendors, where vendor state is equal to CA. So you could go look at the data and see what was in there. So the state is in 2 digits, and who have a 559 area code. So that on the telephone, you're going to have to say like, open parentheses, 559. Oh, it would look like this. Oop. So where vendor phone like, single quote, open parentheses. Remember, it begins with the parentheses. It begins with the parentheses. 559. Get that? And now followed by anything, and that would get it. That would give you the 559. Some people would say like, and they'd put a percent sign at the beginning. I accepted that, but that would find any that had a 559 in the phone number any place. So you could have area code 405-735-591, and it would pick up that one because it's got a 559 in it someplace. So I would use the parentheses. Like I say, I was lenient because I realized that my students weren't sure what the area code was. They thought it was a zip code. And if you think I took off too much on that one or something like that, I'm willing to talk to you about it. Select query, vendor name, vendor state, terms due days. Okay, for vendors who have terms due days greater than 30. So if we go over to my view, Object Explorer, and I'm looking at vendors, tables, look at vendors, look at the columns. Okay. I have a default terms ID. Where is the terms due days? Over in terms, I have terms due days. So terms ID, let's see. So for this one was a little tricky, and I was lenient on giving partial credit. For this one, to get this, I needed to have, excuse me, get it back here. I needed to get to the terms table from vendors. The only way that the terms I can get to the terms from vendors is to go through the invoices table. So I would need to join the vendors with the invoices, and then join invoices with terms to get there. Now, so I have three tables and an inner joins. So I should have that one here. So it would be select vendor name and other stuff there. So basically from vendors as V, enter join invoices as I. So this one was challenging. On v.vendor ID equals I.vendor ID. Now take that, enter join terms as T on I dot terms ID and that's the main part of it, where terms due days is greater than 30, because terms due days is in the terms table, but the terms is not directly related to the vendors table. So because I have to get the vendor name, if all I needed was terms, what terms due days are greater than 30, I could have just said select the terms due days greater than 30 from vendors, but I wouldn't have known the vendor name and the vendor state. So since that stuff came from vendors, I had to have vendors, and I had to go through the invoices table to get there. The temptation was to try to select to try to join the terms on default terms ID. And I accepted that. So if you said if you joined vendors directly to terms on vendors.default terms ID equals terms ID, that's not exactly what it asks for. So for vendors who have a terms due days. So the terms due days comes from the invoices table, and the vendor has a default terms. Anyway, that I maybe need to clarify that one a little bit more. I went ahead and accepted it for I think 9 out of 10 if you didn't do the three-way join. So if you did something that made sense, I accepted it most of the way. 8 and 9 are a little trickier. Again, I'm going to rewrite 8 next time I do it, and I'm going to get rid of this alter table stuff up here because that's confusing everybody. They're going, I don't know what all that means. Okay, fine. I guess I got a little overboard there. What we're looking for is invalid children. Okay, so I should have just said here, if there are any invalid children in the find any. Instead of all that, the idea was if you can't turn on the constraint, something's wrong. What's probably wrong? What's probably wrong is that you have a child with an invalid parent. And you run into this all the time if you're like in a class and they just start throwing data into the tables, but they don't have any constraints set up. Somebody will mistype one of them. Probably more than one somebody will. And then when they go in and they try to turn on the constraint, it won't work. And the students all have their hand up. And that's why I don't like that Shelley Cashman textbook. It does that. And so basically I should have just said, okay, it's find children with invalid parents. Okay, what kind of a join is that? It could be a left or a right. Yeah, it depends on where you put it. It's an outer join that points at the child table, and the child is, let's see, it's invoices. Okay, which one is it here? Yeah, invoice line items and invoices. So in there is one invoice line items that references an invalid invoice. And I should have just told you that up front. So you're writing an outer join, it points at, so at the invoice line items table. So if it's an outer join with, if the invoice line items is on the right, it's a right outer join. If it's on the left, it's a left outer join. And then where the invoices is null, and that will drop it out. It should be one of, I believe it's 999 or something like that, is the offending invoice number. If you made any progress to it, I gave you some credit on that. So basically I was looking for an outer join. If I saw an outer join, you got some credit, even if it didn't work all the way. Number 9 asks you to put together an inner join and an outer join. So this would be the select vendors inner join invoices. So I say show only that are related through INVOICES, and show rows from invoice line items, including unmatched rows. So this one is vendors inner join, and the line I was looking for was vendors inner join invoices on vendor ID, right outer join invoice line items, or you could have put invoice line items first. But invoices has to be joined to vendors, has to be joined to invoices, and then that has to be joined to invoice line items. You can't join vendors to invoice line items. That won't work. Why? Because there's no vendor ID in invoice line items. So that would give you red lines on it. And for the most part, the grades ran fairly good. If there are questions, I'll take them. But anyway, you should have gotten the corrected file back, and so if you email me on that, just make sure you go ahead and set. Oh, I have the file. You can attach the file anyway and your question. Okay. Others. I'm still seeing a lot of people are writing code like from vendors or maybe from something like that. And there's more here, but the main thing is this is a clipped syntax that works in SQL Server. It also works in other platforms. It works most places. In other words, you usually do not have to say inner join and left outer join, right outer join, but you do in this class, okay? And as I see them, somebody's just not listening to me. I've said that several times, so I don't want to see join. Table A, join table B. It's got to be inner join. So anytime I see join, the word that comes before it has to be either inner or outer. Fair enough. Oh, what else? Go. Go goes between create statements. Anytime we create, as we get towards the end of the class, we're going to see more, we're going to create other things. And so when you, if you say create anything, you say go create yabba, 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 whatever it is. Then when you finish that statement and put a semicolon, say go again. Go, I'm indifferent whether you put a semicolon or not. Go is not an SQL statement. Go separates it into multiple programs, essentially. So when you say go, it say, okay, make all of that stuff happen before it. Now start a new program. Okay, so if you're creating a table, it has to be in its own little program. Create the table, go. Create the next table, go. Create the next table, go. Now, when you say select from where, there's no reason we have to isolate that. Select from where will run just fine. It doesn't need to worry about has the preceding statement finished yet. Okay. It might be it might be an issue if you were doing inserts or something like that and then selecting, but actually what'll happen is each one of them will work by itself. And only when you have create do you have to worry about that. Go ahead, sir.
But SQL doesn't go like terms as they order they appear on the document?
Does it go through it in sequential fashion, one after the other? Yeah, not always. You can't count on that in SQL. SQL is unlike other languages in that other languages you can count on them happening in order. If you say print hello followed by print print world, you're going to see hello world. In SQL, you can't necessarily always count on that happening in order. So it can change order on you. If you have go, that says it has to happen, that has to complete before the next one. So if it's important that, and it's important that the creating the table completes before you go select from the table. So if you ever create a table and then you try to select from that table and you get an error message, it says no such field, and you know you got that field because you just created it. What is the matter with this stupid thing? What's the matter with it is you didn't put a go after it. So if you ever find that error. Let's see, other questions. I guess that's my big pet peeve is the syntax of joins. Okay, as I remember others, I'll say them. One other thing, I'm grading the outer join assignment. And I'm a little befuddled as I'm going through it. I'm finding that the assignment says, you know, chapter 6 or whatever it is, module, I don't know, what is it? Modules. Okay. Yeah, it says module 6A outer join assignment, and people are writing subqueries. Now, when we were here, we didn't know anything about a subquery. Subqueries come in the next chapter. 2 chapters down, actually. So we're in subqueries now. So for the outer join, I'm aware that you can write subqueries and do an outer join or an inner join, or almost any kind of a join with subqueries if all of your output comes from a single table, it is meet for a subquery. I can do it without a join. I don't know, there's no way of saying which one is better. And since you should be able to do either or, then I want you to, when we're doing outer join, I want you to do outer join. Humor me. Show me outer join. Then when we get to subqueries, show me subqueries. Enough of that. And we are in correlated subqueries. So I talked about, let's review just a little bit. Let me pause for a second and ask, are there any questions on what I've talked about? Questions about what does something on the test, what does it mean? I'll take in a general question. If it's you think I took off too much on your particular paper, then you send me a message on that. Pausing for questions. The air compressor just cut on here. We're in the robotics lab. Okay, it is important that you get this. You can fast forward through the first part.
It's in Plano, so I can wait till like 5 more minutes if you could like review it.
Okay.
And then I'll be back because I have like class at 2:30.
Okay.
But then I also have to like talk to you on my test.
Okay.
So
you can do that, but just what I'm saying is make sure you get this part about correlated subqueries.
how long is it going to take? I mean, I can still wait. I can stay.
I don't know. I can get through it in 5 minutes. So if you need to go. This is why we have the recording. Just listen to the recording.
I will. And
Okay.
I'll be back before 2:30 because
Okay.
I have class, but then it will get over at 3:45.
I'll be here.
You're going to be here?
Mm-hmm.
All right.
I'll be here, or I'm sometimes I step out for lunch about 2.
But I can email you, right? Before I...
Yes. Mm-hmm. Okay. We talk about subqueries, and in general, a subquery subqueries will, where do we start? Subqueries, here we go, we'll try this one. Okay, a subquery is very handy where everything in the final output comes from a single table. Okay. There's lots of times when I can make it do that, but if it comes from a single table, even if I have to have a join because I want to know something, so vendor ID from invoices where the vendor name contains Joe, I'm going to have the vendors in there, but all the output comes from one table, then it will work fine in a subquery. Select vendor ID from invoices where the invoice total is in, select the maximum invoice total. So this gives me the vendor ID or IDs that had the highest invoice totals. And there might be ties for it. So I could have 3 or 4 of them all tied for having the highest invoice total, and I would get all of them. So it's handy for that. If I needed the invoice total also, I'm going to have to, what if I wanted invoice total? Then no, I should have said, what if I want, okay. So I'm pointing out here I gave an invoice total because I didn't group by. So I'm trying to get the maximum invoice total, but I have to group by vendor ID because remember the rules for that aggregate. So it's very handy having these guys. Now, the next one that we talk about is the correlated subquery. And I get a correlated subquery is a difficult one for students to work with. Let me go here and try it this way. I want to find, for each vendor ID, what is the greatest invoice total? No, excuse me, this one says find the invoices, find the vendor IDs Find the vendor IDs who have the invoice total greater than the average for that vendor ID. So find the vendor IDs and all of the invoice totals that are greater than the average for that vendor ID. Now that's a little strange, but I want you to take all of vendor ID 37, for example. Okay. Take all of vendor ID 37 and tell me the invoice totals that are greater than the average for vendor ID 37. Vendor ID 95. Put all of vendor ID 95's invoice totals together and give me those that are greater than the average for that one. I have 36 rows. Now, if I look at that, let me see, we can, so for example, for vendor ID 95, I have 3 of them. 39 and 77 cents, $32.70, $46.21. So I get 3 entries for vendor ID 95. Now let's look at vendor 95 very carefully. What is the average for vendor ID 95? So if I just run this, I should see the average. So the average is $28.50. 16 rounds down. So what's that?
Or is it that the average is lower than the lowest number?
Okay, the average is lower than the lowest number in there. So the average is lower than any of these. All of these are above the average for vendor ID 95. Let's look at all of vendor IDs.
Not like calculating the average between the 3 invoices?
No, because I do the whole thing. When I execute this, I see all of 95's invoices, and this gives me the average. So the average was $28.50 or so, whatever it was. These 3 are less than that. These 3 are greater than that. And these are the 3 that I'm getting in the output. So for vendor ID 95, I get all of their averages that are greater than the average. Now this is a bit contrived and you don't use these a whole lot, praise the Lord. They're difficult for students to understand, but there are times when you need this that you can't get this with a table join. Okay, so a correlated subquery is different. Now, let's go look at how it works. Let's see. So got average. Okay, so I want it average. I want to kind of group by, if you will. There's ways to get it through joining, but that's just, it's very difficult. I want to group it by vendor ID. And I want all of the invoices that are greater than that vendor ID's average. Or I want to group it by vendor ID, and I want the maximum invoice total for that particular invoice, that particular vendor ID. Then switch to the next vendor ID. Give me his maximum. Okay. Some of those you can get some of those you can do group by. Okay, but the okay, here is what makes this a correlated subquery. Well, it's kind of a join. Okay. First of all, everything is coming from one table. If it doesn't come from one table, I've got a mess on my hands. So everything I want is coming from this pretty much a single table. It is possible to get more, but you're going to get into some serious programming. I'm only going to ask you about one table, And typically it involves something like this, where so from invoices, where the invoice, and I want to group on the vendor ID. Now, basically, I've got the invoices table twice.
What will happen if you erase the where from the subquery?
Don't start messing with it right now. You can take it and ask what would happen, okay, and see what happens. But basically, right now, I'm getting executed. I get 36 rows, and for example, on vendor ID 37, I have 2 invoice totals of the same amount, and those are greater than the average for 37. Now, what if we only had one? What if I only had one invoice? So, for example, vendor ID 30 just has one invoice. Does he have any that are greater than his average or her? No. One invoice can't have any greater than the average. All of our children can't be above average. Okay. So all of these guys have more than one invoice. Some of them have many, like 123, for example, has a whole bunch. Well, vendor ID 123, goodness gracious, but that's one of them from Fresno. Okay, here's the way this works. You have an outside table, invoices as I1. Outside, that is defined outside of the subquery. Then inside the subquery, we have invoices as I2. This is what makes it a correlated subquery. You have an outside table and an inside table, and they are the same table, but they are named differently. So this is like the inside runs all the way through, so it takes the average. The inside table calculates the average running through it, but the outside table gets passed in. Notice that the names here are what differentiate it. So down in the inside table, I can see the outside identifier I1, but in the outside table, I cannot see I2. This is typical in computer science. You will find it to be true that if you define a name outside, and when I say as, I'm really defining a variable name, giving it a name out there. Now this name will be visible inside of this subquery. So when I say talk about this, and when I give another one a name I2, now down here in the subquery, I can see both of them. So I'm interested in the average, where the vendor ID from the inside, where I'm taking the average, is equal to the one that got passed in from outside. Is that making any sense? It's difficult to come up with examples of these. Here's one of them that I found, employee number and a name from employees. So employee number and name have to be in employees. Go ahead, please. What? Somebody is chatting. Thank you. Hello, I need to drop now.
Yeah, that's me. Sorry, Professor. I don't want to, I don't want to, disturb your class. Just say that I need to drop. But I was trying to make exercise, and then I had found to the exercise number 5. This exercise number 7. I have trouble to find the 39th verse. So anytime that I can later, if you can.
Okay. So your question is on number 7 of the
exercise for assignment for this week. Yeah.
Okay. Let's see. I have your. Send me a
sure, I'll do.
Message on that, and I'll try to make sure I cover 7, since other people seem to be saying that they have it. Okay.
Okay.
Correlated subqueries are, it is a correlated subquery. When everything comes from one table. Everything comes from one table. Employees, there it is. It could be a correlated subquery where that wasn't so, and then you would have a mess. It would be very difficult to solve. You're going to have to go into some special cases there. I'm not going to try to do everything in this class, but basically I've got employees and outside, and then the inside, the subquery inside is going to reference the same table. So it's known by one name outside and one name inside the subquery. And usually it references where they are equal. And basically that says, this one is saying, find the employee number and employee name whose salary is greater than, let's see, all other employees in his department. Now, sometimes you can get these using a group by on department. So sometimes these duplicate the idea of group by. I believe that this particular one I could do with group by. And a having, but I don't know, I'd have to try. I don't have a table for this one. Let's see, do I have this one down here? Select invoice, vendor ID, invoice total from invoice. Okay, so this one is max. So this one is finding the maximum invoice vendor ID. I believe I can do this one with a group by and accomplish the same thing. Sometimes you can and sometimes you can't. So just because it all comes from one table doesn't mean that you can do it. The correlated subquery is probably the most difficult of our concepts. The subquery is most useful when all of your output comes from a single table. Okay, the correlated subquery becomes useful there. Any subquery is, I like subqueries when I look at it and I see everything is coming from the same table. I start thinking of subqueries immediately because to me, they are more intuitive than a table join or a group by. But I can't always do that. If I have to select stuff, if I have to have stuff coming from two or more tables, a subquery doesn't work as well. Okay. Questions? Okay, I'm going to continue on, and I don't have a whole lot more to do today. I'm going to wrap up. I'm going to wrap up subqueries and make the assignment, and I'll cover number 7 while we're here today. Let's see, where is my derived subqueries? Okay, I've seen the subquery in the select vendor name, MyMax, that sort of stuff. I've seen subqueries in the where clause. So up until now, we've always had the subquery has been part of the where clause, and we've been using it to validate what we wanted. So I want the maximum. So select the maximum from some table where select the value I'm looking for. Select the invoice total from invoices where invoice total in select max. So I'm using the where. The subquery is coming in the where clause, and that's usually the case. Most of the time you see the subqueries in the where clause, just 9 times out of 10. But subqueries can be in the from clause also. So a subquery, remember I told you that a query was simply a table. The output of a query is a table. Therefore, I can select from a query. And here is one example of where that's the case. Let me run this down where I get it all on here. Let's see. Okay. Select vendor name, MyMax, from. Now the from is a query. The table I'm selecting from is a subquery. Yes, you can do this, and yes, it's very handy. Some points about this. So here's one. It says select vendor ID, vendor name, max payment total as my max. Vendors, enter join invoices. So I'm hiding, essentially I'm hiding this subquery down in the from statement. And there's another way we can do this that we're going to cover. But for right now, that'll be fine. I'm creating a table using a query to create a table. And I'm treating that query as if it were a table, because in fact it is a table. It has all of the rights and privileges of any other table that's in our database, including I can join it with other tables, which gets a little strange, but it's this is called a derived table. Some things about a derived table. I can only select from it those things that are in the output of that table. This is handy when I need to hide something from the end user. So I want this output of this query to go out to the web, but let's see, the vendor name, the vendor ID is confidential. So I want this to be pushed out to my web server, and I want the whole world to be able to see the vendor name and the the maximum payment total. But I don't want you to be able to see vendor ID, because that's like your social security number. I'm not allowed to show people that. But I have to have it in the question, because in order to get from vendor name to payment total, I have to go through the vendor ID. So the vendor ID has to be in the query, but I want to hide it. So I can push it down into this subquery. This essentially hides this vendor ID. Some points about a subquery that's done like this. Number one, all of the fields in the subquery must be aliased. So if I'm not down in a subquery like that, I can get away with not having a name. So I could say, you know, I could not say as my max, and it would just say no name on the column or something like that. That's very bad, though, by the way, to have a query with no name, but it'll work. In others, it will be named max payment total, in Oracle, for example. In SQL Server, it just says no name. Okay, but if you're going to use it as a derived table like this, if you're going to select from it, then all of its fields have to be named. If I don't name it, I will get, for my reading pleasure, an error message. Notice it's already turning red, saying, gee, you can't do that. Can't get away with that. I have to name it. The other thing that you have to do is you have to name the query. The name of this table that we are putting in there as a subquery is D. I usually name it D for derived table. That's my typical name. It can be terse. It's not going to be seen anywhere else. Now I can take D and join it with any other table. And it's D dot vendor ID equals dot, you know. Okay. So if I wanted to, I could select vendor ID, but if I don't select vendor ID, it is hidden. We're going to see this again come in I guess to a couple of weeks, end of the month sometime. This is going to pop up again for us, and we're going to see not only can I use it as a derived table, but I can take that query, this one, and I can say, save this in the database, pretend like it's a table. But if somebody updates the table, update this one too, and let people use it as a table. So I can create that name D, and I can say, okay, make this make this name associated with this subquery. I guess I could show you how to. I'm afraid I would just obscure the matter if I talked about how you do it. It's not important how you do it right now because we're not doing it right now. We'll be doing it later. But basically I say, okay, take that query, name it D, make it be a table, but don't duplicate the data. Every time you select something from D, you're really going out to those tables and selecting it. And it's handy because now, well, I get it, but it's my max is not an alias. My max is really the name of this field in this table. I can join this table with anything else. Okay, so the main thing to remember about derived tables when they are in the from line. So you can select from them. You're treating the query as a table. The parentheses, again, are required. All of the fields in the subquery must be named. Sometimes I get sloppy in subqueries, and I won't name all of my fields, particularly if they're not being passed back. I don't, if I've got a max, for example, when I was selecting the max, I didn't have to name that field. Sometimes I don't. So if I, select the max, select max from max invoice total from invoices, I didn't have to name that because I was just saying, is it in there? But this one, where I'm actually using this value and I'm passing that value out to be put out by the higher level query, it has to have a name. And the query has to have a name, and that last one is my favorite one to forget. And I'm always sitting here tearing my hair out going, why won't it take my derived subquery? Well, it won't because I forgot to name it. Textbook is pretty good on this one. So let's see, we're a little past. Let me go to look at this one. I've had the question then on the subqueries. Chapter 6 quiz. Okay, here's the module 8 exercises. A lot of these are this is a changing the correlated subquery. Let's see. So the question came in on number 7. Let me see if I've painted myself into a corner on that one. Number 7. Write a select statement that returns the vendor name, vendor city, and vendor state. Okay. Everything is coming from one table. That means it is meat for a, Okay, yeah, this one is a little tricky. I remember this one. First, let's see. So I want that is located, should be located in a unique, I guess I need to change that right now, located. Located in a unique city and state. In other words, do not, let me go ahead and save it. I'll go ahead. I'm going to make this due, by the way. So, I mean, I'm going to assign it now. Yeah. Yes, this one is a bit challenging. So, in other words, do not include vendors who share a city and state with any other vendor. Now, it would be where the count group by city state having count less than having count equals 1 might work. Basically, vendors. This one comes from a subselect, so that we want to get the vendor name, vendor city, vendor state. Okay, first write a select from group that gives you, what's that? City-state pairs. And filter the count in the having clause. Test it, you should see 39 pairs. Now to get the vendor name, you join that query as a derived table, okay? And we'll still have 39 rows. Let's see if this is making any sense to me. So I'm gonna write this first one. This one came from the book. I'm gonna write this part, first write a select from group that gives the city-state pairs. Okay, I think we can do that. New query, use. Select. Yeah. Vendor city. Vendor state. Count. Okay. I guess I might need that count. I don't know whether I will or not. I'll try it from vendors. Now, clearly, I'm going to have to group by. So by the rules, they say if I have a aggregate and a non-aggregate, I must group by the non-aggregate. So I'm going to have to group by both of them. Having. First of all, I'm going to just try this. I've got 53 rows. So let's just, I want the unique ones. I'm getting 38. So I don't know why I was having 39. So the data have changed a little bit, so don't worry too much about it. I don't think I'm going to need this in the output. I don't think I'm going to need to have that count. So I think I can just say vendor city, vendor state, from vendors, group by, because I can group by even if I don't have an aggregate. So this should give me my rows. So there are the pairs, my vendor cities and vendor states. Okay. And so I don't need the count as part of the output, because if all I'm going to do is see one, I don't need to see 1, 1, 1, 1, 1. That's not telling me anything. So there's no point in even putting it. So there's that's going to be my derived table. Back and look at it again. So it says 39 pairs. I'm seeing 38, but the data may have changed. Now join that query as a derived table with, okay. Yeah. So that's part one of it. Now I'm going to take this and I'm going to say select vendor name, vendor city, vendor state, from vendors as V, okay. That's where the vendor name is. That's where all that stuff is. Inner join. Inner join what? This one will be tricky to format. When I open a subquery, I sometimes come back to the beginning of the next line, because the subquery is going to kind of get long. If I open my parentheses here, I'm going to be scrolling off the page. I'll just have to look at it later and see how to format it. Here's where I'm pay a little bit of attention to your format. Try to make it look as good as you can. So from what? From inner join what? Inner join that. Paste. Okay, have I named everything up here? Yes. What's the last thing I have to make sure I do? It has to have a name. Now, what happened here? Why are they going red on me? They weren't red a minute ago. What's that? Yeah, I'm using vendors table twice. which one of them am I talking about, okay? Actually, it isn't going to matter. I can say, I'll be able to take it from either one. But basically, let's look at what our on clause is. So as D, so I've got vendors, I've got V, inner join D on V dot vendor city equals D dot and. You can have an and clause in the join. I don't think I need a where. Okay, and now we just need to resolve this. This is an ambiguity up there because I've got vendor city and vendor state in both vendors and in both V and D. I'm not getting it on vendor name because vendor name isn't in the derived table. So I just have to choose which one. I could do it with V or D. I think I'm going to get exactly the same output. Doesn't matter. I think I could say either one because they are equal by that line right there. They both have to be the same. So it really doesn't matter which one. And here we have the final output. And I still have my 38 rows. And on any of these, so let's throw an order by in here so we can see a little better. Order by, what should I order by first? I'm going to order by state. Order by vendor state. And all that is just to let us see if there are any duplicates. We will see them better. So all California, I should, down through here, I should only see one state or one city per, I should not see any duplicate cities. Seems like I've got, did I add? Yeah, they're Dallas, Texas. I added a few others in there and made some changes. I think I don't know how Dallas, Texas got in there, but I've changed some of these data. So you can't necessarily count on there being 38 rows or 39 rows. Whatever we get in this final output should be the same number of rows and the same cities and states that we got in this one when we put that together. So number 7 does use a derived table. It's a little bit tricky, but it's not. I'm not going to put this out in writing. You guys got to listen to the recording to get that. So anyway, there. So I guess I'll know who's viewing the tapes and who isn't. Questions, please. Questions. I'm about to wrap up here.
I'm good.
Okay. Well, you got number 7. If you're watching the lecture to the end, then you know number 7. Let me see if there's any other tricky ones in here. I didn't talk about number 8. Number 8 is a little easier. Inner join vendors and invoices, and then inner join that with the derived table. Yeah. This number 8 isn't as tricky. What's up?
I had problems on 4.
some problems on 4. Oh, you guys are such whiners. Let me see what we got. Select statement, 2 columns from the GL accounts, general ledger accounts table. Account number, account description should have 1 row for each account that has never been used. This is essentially a an outer join that I want it written as a subquery. All of these guys are written as subqueries. So when you were writing outer joins and people wanted to write them as subqueries, now you'll probably want to write subqueries as outer joins. But this one is an outer join, and most of the time, it's meet for an outer join. It is a childless parent. So the GL accounts is the parent, and the it was in the outer join, so it's the same thing. It would have identical output. So the parent table is the GL accounts, and the child table is what? Invoices, I believe. Yeah. Invoice line items, okay. So parent is GL accounts, child is invoice line items, and it's a childless parent. So it says, you know, you want everything from the GL accounts table. Everything is coming from one table. And a childless parent table, a childless parent query does very well as a subquery. It's pretty straightforward. Just if you think about it just a little bit, you'll figure that one out. I don't think I should do that one necessarily. If I give it to you on a test, I'm going to say, I want to see a subquery here. Write a subquery or write an outer join. So you should be able to write either an outer join or a subquery. Given that everything is coming from one table, it's meet for either one. So if I ask just to find unmatched, just find invalid children, you can do that with a subquery or an outer join easily. My own personal thing, I would go for a subquery, but you can also do it with outer join. Okay, let's see, 12:30 something. Wrapping up. I'm going to make this due, a week-ish. I'm going to start, I'm going to grade it at a week. By the end of 2 weeks from today, okay, so let me edit it. Okay, so it is due, today is the 16th, it will be due on the 23rd. That is the due date. I'm going to have it graded by the 30th and returned to you. Okay, so if you have it to me by the 30th, I will return it to you by then, and if there's any changes that need to be made to it, then you'll have time to make them. On the November 6th, it turns into a pumpkin. I am not going to open it again. So if you don't have it turned in and returned to you, so if you get it to me by the 30th, I will get it back to you, and you will have a week to make any corrections you need to make. If you are late, if you are past the 30th getting it to me, I won't guarantee I will get it back to you with time to make corrections. If you haven't gotten them made and in by the 6th, forget about it. I don't want to hear it. I'm not going to reopen it. Okay. So that's the Intel November 6th. Tick-tock, that game is locked, and don't email it to me. So I'm giving you 3 weeks. It's due in a week, but that's soft. It's pretty much, I'm going to grade it in 2 weeks, and that's getting a little tougher because if you don't get it in by then, you won't necessarily get it graded and back to you by the cutoff date. And then the cutoff date is the 6th. Okay. I'm going to end the recording there. Stopping the recording.